Okay, so the next part of this session is solving previous year's question. We will start with 2019. 2019 ka first question was from this lesson is Cp, Cv are molar specific heats, gamma is adiabatic constant, R is universal gas constant, then Cp specific heat at constant pressure is equal to, इनमें से कौन सा है? Now pause the video for 2 minutes and just try to solve this question, whether you can solve it or not. Okay, so let us see कोणाकोणाचं बरोबर आलं. So straight away if I see कि specific heat विचारली है, specific heat which at constant pressure, तर obvious answer ही नहीं है, because this is dimensionless unitless quantity and specific heat ला तर dimension unit आहे. So this is obviously wrong choice. So no one should go with this choice, at least हे नसेल येत तरी, right? So सगळे C वाले ज्या सगळे C मारणारे लोकांसाठी हा धोका आहे. You cannot mark C over here. So let us check the other options, or we will see how to solve this question. We know two equations, Cp by Cv is gamma and Cp minus Cv is R. Obviously from these two equations we are interested in Cp and not in Cv, so we need to eliminate Cv. So Cv का replacement क्या है? Cv can be replaced as Cp by gamma. Cv is replaced as Cp by gamma. I will put it over here. So Cp minus Cp by gamma is equal to R. Common का ये, common is Cp. If I take Cp common, what is left in the bracket? Gamma minus 1 upon gamma into R. So the answer is Cp is equal to gamma R upon gamma minus 1. The answer that matches this particular solution is A. So question number 1, answer is A. Okay, so this is the second question from CET section. And this is again asked in the same exam, 2019 CET exam, and the question is based on the thermodynamics section, that is refrigerator. Alpha is COP, coefficient of performance of refrigerator, and Q1 is heat released to this reservoir, hot reservoir, then heat extracted Q2 is what? Okay, so हा question चालू करण्याच्या आधी just pause the video and तुम्ही try करा first किचा आन्सर तुमच्या ह्याच्याने काय येते तुमच्या पॉईंट ऑफ व्ह्यूने. तुक्के मारणारे तुक्के मारू शकतात, बट आयडियली तुम्ही सॉल्व करून आन्सर काढणं एक्सपेक्टेड आहे. जस्ट पॉज द व्हिडिओ फॉर 2 minutes, सॉल्व, ट्राय टू सॉल्व विथ द क्वेश्चन अँड अगेन कम बॅक. ओके, सो ज्यांनी सॉल्व केलं असेल तुमचा आन्सर चेक करू शकता. यू कॅन चेक युअर आन्सर. दिस क्वेश्चन इज बेस्ड ऑन रेफ्रिजरेटर वाला सेक्शन. मीन्स दिस इज रेफ्रिजरेटर इन विच heat should be extracted from the cold surrounding, which we call Q2. W is the input work that we give as electrical input, and दोनों मिला के you get output as Q1. You give out heat to the hot reservoir. Refrigerator में we remove the heat from the cooler section and give it out to the hot part, that is the higher temperature reservoir, right? And the coefficient of performance is defined as desired input, जो निकालना है desired input upon output, and desired output, the heat that we want to remove, divided by input, which is the work, electrical work that we do. And since we know the relation, we can write it as Q1 minus Q2 as alpha. Okay, because Q1 is W plus Q1 is what? It is Q2 plus W. So W can be replaced as Q1 minus Q2. And now I want to find Q2 because I know Q1 and alpha. Q1 आणि अल्फाच्या टर्म्समध्ये Q2 काय येईल? जस्ट व्हेरी सिम्पल, क्रॉस मल्टिप्लाय करायचे, Q2चा आन्सर काढायचे. फर्स्ट थिंग व्हॉट आय विल डू इज, इथे 2 Q2 आहेत, 2 Q2s, राईट? सो आय विल ट्राय टू मेक इट अ सिंगल Q2. आय विल टेक अ रेसिप्रोकल ऑफ दिस. ओके, ह्याचा रेसिप्रोकल घेणं फायद्याचं राहील. इट विल बिकम Q1 मायनस Q2 अपॉन Q2 इज इक्वल टू 1 बाय अल्फा. अँड इफ आय स्प्लिट दिस इट विल बिकम Q1 बाय Q2 मायनस 1 इज 1 बाय अल्फा. And minus 1 पलीकडे गेला तर plus 1, which becomes 1 plus alpha upon alpha is Q1 by Q2. So what will be Q2? Q2 पलीकडे multiply केला तर Q2 will be, alpha will go up, alpha upon alpha plus 1 into Q1. So the answer which is matching this particular solution is C. Question number 2, answer is C. So the next question, okay, so the next question in the series from previous year's CET exam questions 2018. आता फॅमिलियर क्वेश्चन तुम्हाला वाटेल बिकॉज 2019 मध्ये असाच क्वेश्चन आलेला, जस्ट तिथे विचारलेला CP. बट आय वुड से की तो क्वेश्चन ह्याच्यापेक्षा थोडा डिफिकल्ट होता बिकॉज त्याच्यामध्ये ॲक्च्युअल सॉल्विंग वॉज रिक्वायर्ड. इथे थोडासा सॉल्विंग नाही, इथे कॉमन सेन्स रिक्वायर्ड आहे. बिकॉज हा क्वेश्चन तुम्ही अप्रोच करताना यू विल ट्राय टू सॉल्व इट. मगाशी जसं केलं 2 इक्वेशन 2 आन्सर लिहिणार, 2 इक्वेशन आणि सॉल्व करणार. पण इथे थोडंसं कॉमन सेन्स प्रेझन्स ऑफ माइंड पाहिजे. मी मगासपासून सांगतोय की इफ दिस CV इज आस्क्ड स्पेसिफिक हिट ॲट कॉन्स्टंट व्हॉल्यूम, वी नो दॅट, तुम्हाला डेरिवेशनमध्ये सांगितलेलं मी, इट इज du/dt राईट, आणि त्याचा आन्सर येतं आपल्याला काहीतरी. सो इट इज अ युनिटवाला नंबर, इट हॅज सम युनिट. तुम्ही नीट बघा, ऑब्झर्व करा आन्सर्स. तुम्ही हवं तर पॉज करून आन्सर सॉल्व करून बघा आणि नंतर व्हेरीफाय करा तुमचा आन्सर येतं आहे का. बट दिस क्वेश्चन विल हार्डली टेक 2 to 3 seconds टू सॉल्व. ओके, सो आय टेल यू द सोल्यूशन. फर्स्ट, this is a dimensionless number, unitless dimensionless, so this cannot be the answer. Unitless dimensionless, this cannot be the answer. हां, ह्याच्याकडे युनिट आहे पण हे 1/r चं युनिट आणि CVचं युनिट r चं युनिट सेम असतं. सो दिस कॅनॉट बी द आन्सर बिकॉज r इज इन डिनॉमिनेटर. सो दिस इज द राईट आन्सर. दिस इज विदाउट इवन सॉल्विंग, विदाउट इवन रायटिंग अ फॉर्म्युला. CVचं युनिट, CV specific heat at constant volume चं युनिट r सारखं असतं, सेम ॲज r. सो ऑब्व्हियसली द आन्सर कंटेनिंग r, ह्याच्याकडे तर r नाही आहे, ह्याच्याकडेही नाही आहे, द नोट r इन दिस 2 ऑप्शन्स, ह्याचा तर r डिनॉमिनेटरमध्ये. सो द ऑब्व्हियस चॉईस वुड बी डेल्टा. सो विदाउट इवन सॉल्विंग यू कॅन गेट द आन्सर. 2018ला आला आहे, 2019ला रिपीट झाला. जस्ट CP वॉज आस्क्ड, दॅट क्वेश्चन वॉज स्लाइटली डिफिकल्ट बिकॉज ऑल ऑप्शन्समध्ये एकच ऑप्शन डायमेन्शनलेस होता, बाकी तिन्हीमध्ये ऑप्शन्स होते. In this, answer is delta. How to solve it? So obviously CP minus CV is equal to R, CP by CV is equal to gamma. We will try to eliminate CP. CP का, what will be the CP का replacement? CP will be gamma into CV. I will replace this CP over here. So CP का replacement is what? Gamma CV minus CV is equal to R. CV common, gamma minus 1 is equal to R. Gamma minus 1 गेला खाली, R upon gamma minus 1. This is the answer for question number 3, delta. हे सगळं अवॉइड करू शकला असतं, हुशार असतात. ओके, सो 4th क्वेश्चन, MHTCET 2018चा दुसरा क्वेश्चन. 2018 CETचा सेकंड क्वेश्चन. फर्स्ट क्वेश्चन तर इझी होता, हा बघा सेकंड क्वेश्चन, हा पण काही अवघड नाही. हीट एनर्जी इज इन्सिडेंट ऑन द सरफेस ॲट 1000 जूल पर मिनिट. एका मिनिटात 1000 जूल इज इन्सिडेंट. 0.8 absorbed, 0.1 reflected. Coefficient of absorption is 0.8, coefficient of reflection is 0.1. Then heat energy transmitted in 5 minutes is what? Options are given. Pause the video, try to solve it, come back in 30 seconds. Very simple question, hardly it will take 30 seconds. Well, so those who have solved, you can check your answer. What should be the answer? See, coefficient of absorption is 0.8, coefficient of reflection is 0.1. So obviously A plus R plus T हे जे 1 असतं addition. So what is the remaining part? 0.9. Coefficient of transmission is 0.1. Coefficient of transmission is 0.1 means if 1 joule is incident, 0.1 will be transmitted. So if 1000, or else I will write the formula. Coefficient of transmission, what is the formula? Amount of heat transmitted upon amount of heat incident. What is incident heat? It is 1000 joule is incident every minute. 1000 joule is incident every minute. So how much will be transmitted? Every minute, the amount of heat that will be transmitted is 100 joule each minute. But question is not every minute, in 5 minutes. Option पहिलाच ठेवला आहे त्यांनी या लोकांसाठी 100 वाल्या. So 5 minutes मध्ये क्वेश्चन विचारले, 5 minutes मध्ये how much energy will be transmitted? So the answer is beta, that is 500 joule. Question number 4, answer is beta. Okay, so the next question, the 5th one from previous year's series 2017 MHTCET. The question is, two spherical black bodies of radii R1 and R2, their surface temperatures are T1 and T2. If they radiate same power, then what is the ratio of R2 by R1? This question is based on emissive power. So pause the video and try the question for some time. It will take 1 minute to solve this question. You can solve it quickly as well. So try this question and then check your answer. Okay, so the answer for this question, the solution is in this way. Their surface temperatures are T1 and T2. Their radii are R1 and R2. They radiate same power. Now emissive power is Q by AT. Emissive power is different and only power radiated is different. This is normally power radiated, amount of heat radiation emitted per unit time. So they have same power. So basically they have same E into A, right? They have same E into A. Their emissive power into area is same because they radiate same power. So I can say A1 E1 is equal to A2 E2, and according to the formula, emissive power of black body is sigma T raised to 4. So sigma T1 raised to 4, what is the area of a sphere? 4 pi R1 square is equal to 4 pi R2 square into sigma T raised to 4, sorry, sigma T2 raised to 4. Solving this, R1 will go down, R2 square by R1 square is T1 upon T2 raised to 4. Taking the square roots, you will get R2 by R1 as T1 by T2 whole square. So the answer for this question is C. C वाल्यांना हा पण करेक्ट येईल, C तुक्के मारणारे जे आहेत. So for this question answer is C. R2 by R1 is T1 by T2 raised to 2. Okay, so the next question in CET section, sixth question asked in CET 2017 exam. This question is formula based. Directly the formula is asked. An ideal gas of pressure P, volume P, temperature T, and mass of each molecule is m, Boltzmann constant is k, and what is the density of the gas? You can stop the video and try to solve the question. Tell me what should be the answer. तुक्के मारणारे C म्हणतील, but let us see what should be the answer. We have to solve the question. So how to solve this question? Okay, so let us see how to solve this question. We will start with ideal gas equation, PV equals to nRT. In this particular example, m is the mass of each molecule. Okay, m is the mass of each molecule. Now the question is, what is the density of the gas? Density is mass by volume, right? Density is mass by volume, and mass of the gas is mass of each molecule times Avogadro's number, or sorry, times number of molecules. Mass of each molecule is mass of the gas is mass of each molecule into number of molecules, and number of molecules upon Na is number of moles. So I have to adjust Na. I will adjust that Na part. Na is Avogadro number. So this will give me number of moles upon volume into Avogadro number is density. And how can I put the value of this particular section? This N by V is nothing but P by RT. I will replace that P by RT over here. It becomes M Na P by RT. Can you tell me what is N by Na by R? R by Na, we know it will become MP upon R by Na into T, and this is nothing but K. So answer is PM by KT. Answer is A. PM by KT is density of the gas. Is there any other method? Is there any other approach? Possible approach असा आहे की density is mass by volume. Correct? Density is mass by volume, and pressure into volume is RT, nRT. N is dimensionless. So pressure into volume is RT. बराबर ना? So volume should be RT by P. So mass by volume is RT by pressure. So वरतीच pressure जाणार, PM वरती आणि RT खाली पाहिजे, PM वरती आणि RT खाली पाहिजे, R नाही Na आहे इथे, because this M is mass of each molecule, not the mass of the gas, right? So the answer is A. Okay, so question number 6, the solution for question number 6 is this, and the answer is A. Straightforward question, formula based question होता. Density of the gas was asked. Even dimensionally you can check कि mass वरती पाहिजे, हे तर नाहीच possible. Mass खाली आहेत, mass वरती पाहिजे, हे किंवा हे. आता pressure into temperature we never do. Pressure इकडे and temperature पलीकडे असतो. You cannot multiply pressure and temperature. The dimension cancelच नाही होणार. So pressure temperature is not possible. This one is possible. So obvious choice is A. Sixth one, answer is A. Okay, so the next question is the seventh one. CET 2016 exam question, very simple question. You can read the question. Pressure exerted by the gas can be shown as कायनेटिक एनर्जी पर युनिट वॉल्यूमच्या काय कुठला फ्रॅक्शन 1/3, 2/3, 3/4 का 3 सेकंड 3/2. What do you think? So kinetic energy का formula we have studied. Kinetic energy is half mv² for any object mechanics मध्ये, but mechanics नाही, kinetic theory मध्ये it is half m CRMS². आणि नंतर ह्याचे व्हेरिएशन्स, कसे व्हेरिएशन्स आहेत त्याचे? इट बिकम्स 3/2 PV, it becomes 3/2 nRT. So since kinetic energy चा हा फॉर्म्युला आहे, what will be kinetic energy per unit volume? It will be 3/2 P. So pressure exerted by the gas can be written as 2 वरती 3 खाली 2/3 of kinetic energy per unit volume. Very simple question. Answer is beta. Okay, so the last question of this MHT-CET question solving series. 8th question 2016 MHT-CET exam. The question was asked: a black rectangular slab of area A emits E energy per second at 27 degrees Celsius. If length and breadth are reduced to 1/3, length 1/3, breadth 1/3, मतलब area 1/9 of the initial value, and temperature is increased to 327, then energy emitted per second becomes. What should be the answer? You can try for some time, pause the video and then check your answer. Okay, so I'll solve this question. See, energy emitted per second, मतलब Q by T is asked. And since we know that Q by 8 is sigma T raised to 4, what will be only Q by T for a black body? It will be A sigma T raised to 4. This is asked. So this particular part, energy emitted per second, is directly proportional to area and temperature raised to 4. Energy emitted per second is proportional to area and temperature raised to 4. So energy emitted per second in the second case which is asked upon energy emitted per second in the first case which is E is equal to area in second case upon area in first case, temperature in second case upon temperature in first case raised to 4. What is area in first case? A, right? What is area in the second case? In the second case, area will become breadth or length 1/3 कर लिया. So length 1/3, breadth 1/3, so area becomes 1/9. Obvious it is A by 9. Temperature in the first case is 27, that is 300 Kelvin. And what is temperature in the second case? 327, मतलब 600 Kelvin. इन दोनों का raised to 4. This will become 2. 2 raised to 4 is 16. AA will cancel. 16 by 9 is E2 by E1. E1 is originally E, so answer is 16 by 9 E. Option is delta. Question number 8. Answer is delta. So these were the questions which were asked in previous 4 years, 16, 17, 18 and 19 MHT-CET exam. This will give you a clear idea that the level of questions that have been asked in CET exam. You can see all the questions were strictly based on CET syllabus, strictly based on state board syllabus. Not even a single question was asked was out of the scope of the Maharashtra state board textbook. So make sure you study all the content from the textbook first before solving any other things, right? So after this we are going to start with assignment sheet. Please make sure that you have assignment sheet in front of you because I am directly going to start with the assignment questions after this. Okay students, so now we will move to the third section of this session, that is solving questions from the assignment sheet. Everyone has got assignment sheet given to you, and let us start with the first question. Have a look at the first question. The molecular weight of the gas is 44. The volume occupied by 2.2 gram of this gas at 0 degree Celsius and 2 atmosphere will be. So in this question, volume is asked. This question, what is the given data? The molecular weight of the gas is given. Molecular weight is given 44 gram, right? Unit is not given, but normally molecular weight is always given in gram. Then the mass of the gas, this is molecular weight, and the original mass of the gas is 2.2 gram. So from this you can calculate the number of moles. Number of moles का formula क्या है? Given weight upon molecular weight, right? So given weight is 2.2 divided by molecular weight is 44. If you solve this properly, what I can do is, see, I will shift 1 0 first of all. It will become 22 into 10 raised to minus 1. Why I have done this? Because 22 ये 44 का half है. So it is half into 10 raised to minus 1. That is 0.5 into 10 raised to minus 1, which is 0.05 mole. This is number of moles. Indirectly it was given, correct? So number of moles are given and the question is at 0 डिग्री टेम्परेचर कितना है 0 डिग्री मतलब 273 केल्विन एंड रियल गैस कांस्टेंट सॉरी यूनिवर्सल गैस कांस्टेंट का वैल्यू इज 8.314. So everything is given. Pressure is also given 2 atm. Now we know 1 atm ka conversion is 1.013 into 10 raised to 5. I will just neglect this part which is very negligible as compared to the number. So 1 into 10 raised to 5 is the pressure given in SI unit. R is in SI unit. Temperature is in SI unit. Number of moles are given. Question is what is volume. So if I use ideal gas equation, the first question is straightforward question based on ideal gas equation. आणि ह्याच्यामध्ये व्हॉल्यूमचा फॉर्म्युला काय येईल NRT बाय VP. आता सिम्पली यू टू पुट द डेटा अँड सॉल्व टू गेट द राईट आन्सर. ओके सॉल्विंग बघा आता नंबर ऑफ मोल्स इज 0.05. सो आय विल राईट इट एज 5 into 10 raised to -2. व्हॉट इज रियल गॅस कॉन्स्टंट 8.3. 8.3ला मी असे लिहू शकतो ठीक आहे 8.3 आय कीप इट ॲज इट इज 8.3. टेम्परेचर इज 273 आय कीप इट ॲज इट इज 273 डिवायडेड बाय प्रेशर इज 2 बट 10 raised to 5. करेक्ट 10 raised to 5 10 raised to -2 सो काय होईल 10 raised to -7. 5 into 8.3 8 5 जा 40 असतो रफली आणि हा 0.3 मल्टिप्लाय केला तर 41 होतो. 41 into 273 upon 2 हे जर काही डिवाइड केलं तर ऑलमोस्ट 20.5 येईल. आय विल अप्रॉक्सिमेटली टीट ॲज 20. हे 0 ह्याला दिला दिस 0 इफ आय गिव्ह इट टू 10 raised to -7 इट बिकम्स 10 to the power -6 आणि 2 into 273 राहील हा 0 गेल्यावरती 2 into 273 विच इज 273 का डबल दॅट इज 546 into 10 raised to -6. ऑब्वियसली व्हॉट इज द युनिट SI युनिट ऑफ व्हॉल्यूम मीटर क्यूब. आता नीट ऑब्झर्व केलं तर लिटरमध्ये आन्सर्स दिलेत नॉट इन मीटर क्यूब. सो मीटर क्यूबचं लिटर कसं कन्वर्ट करणार 10 raised to 3 liter. 1 meter cube you must know this 1 meter cube is 10 raised to 3 liter. Right? So 10 raised to 3 liter, 10 raised to -6 मध्ये 10 raised to -3 is left, and if you multiply it over here, it will become 0.546 liter. The closest answer for this is option delta. So first question answer is delta. So now read the second question. The molecular weight of oxygen and nitrogen are given, which we already know. Oxygen is 32, nitrogen is 28. 15 degree la. At 15 degree, pressure of 1 gram of oxygen will be same as that of 1 gram of nitrogen in the same bottle at the temperature. At which temperature? Means ही bottle आहे. In this bottle oxygen 1 gram of oxygen किती टेम्परेचरला आहे 15 degree Celsius. आणि ह्याच बॉटलमध्ये 1 gram नायट्रोजन घेतलं मी. इफ आय टेक 1 gram नायट्रोजन at what temperature I should keep that nitrogen so that both will give the same pressure. दोघांचं pressure same राहील. Again the second question is based on ideal gas equation, that is PV equals to nRT. So दोघांचं pressure same करायचं असेल means I should equate nRT by V of both oxygen as well as nitrogen. Oxygen साठी nRT by V should be equal to nRT by V for which gas? Nitrogen. For both of them pressure is same, clearly mentioned. So इकडे temperature काय पाहिजे? What should be the temperature in this case? That is the question. What will cancel? RR will cancel because R is constant. V volume same bottle है, so volume is also constant. Whether I can cancel number of moles 1 gram 1 gram. See, even though mass same असेल, number of moles are not same because number of moles is mass upon molecular mass into temperature is mass upon molecular mass into temperature. This mass is 1 gram for oxygen, 1 gram for nitrogen, so it will cancel. But molecular mass for oxygen is 32, for nitrogen it is 28. Temperature for oxygen is 15. Should I put 15? इथे 15 पुट करता येईल का नाही because ideal gas equation मध्ये this temperature is the absolute temperature, so I need to put plus 273, that is in Kelvin, and that will come out to be 288 Kelvin. तर इकडे टेम्परेचर किती येईल T2. सो 4च्या टेबलमध्ये 7 जा 8 जा 8 3 जा 24 48 8 6 जा 48 राईट. सो 7नी क्रॉस मल्टिप्लाय केलं तर टेम्परेचर ऑफ नायट्रोजन गॅस शुड बी 36 into 7 42 7 6 जा 21 plus 25, so 252 Kelvin. This should be the temperature of nitrogen gas. But if you see that options are given in degree Celsius, so 252 केल्विन म्हणजे किती डिग्री सेल्सिअस, तर ऑब्व्हियसली नेगेटिव्हमध्ये येईल डिग्री सेल्सिअसच्या, बिकॉज 273 म्हणजे 0 डिग्री असतो. सो याच्यातनं -273 करावं लागेल. And the answer that you will get will be -21 degrees Celsius. So question number 2, पण option is dead. Okay, the third question is, an electron tube was sealed off during the manufacturing at the pressure of 1.2 into 10 raised to -7 mm of Hg, mm of mercury. Now this is a way of expressing pressure. We will see how to convert it at 27 degrees Celsius and volume is given. Now what is this electron tube? First of all, cathode ray tube construction होता आपल्याला modern physics मध्ये. In that we try to maintain low pressure inside the tube. So how to maintain low pressure? We evacuate the tube and then seal it off. त्यावेळेस थोडाफार गॅस राहून जातो, थोडेफार एअर मॉलिक्युल्स राहून जातात. सो ते फाइंड करायचं आहे. सी व्हॉट इज द क्वेश्चन. दिस इज इलेक्ट्रॉन ट्यूब अँड फ्रॉम दिस एअर इज रिमूव्ड आउट, अँड वेन यू रिमूव्ह आउट द एअर द प्रेशर इनसाइड दिस ट्यूब ड्रॉप्स. किती ड्रॉप झालं प्रेशर? द प्रेशर इनसाइड द ट्यूब इज 1.2 into 10 raised to -7 mm of Hg. How to convert this mm of Hg into Newton per meter square? Conversion बघा. If mm of Hg is given, you can convert it into pressure using the formula of H rho g. This is the formula of converting height of mercury into the pressure. This is in fluid mechanics. How to convert this? So the formula that you can convert mm of Hg pressure into Newton per meter square. So if I put the value, किती आहे? It is 1.2 into 10 raised to -7 mm आहे. So if I convert it into meter, it will become 10 raised to -10 meter of Hg means mercury. Density of mercury you must know, it is 13600 kg per meter cube SI unit, and g acceleration due to gravity can be taken as 10. So हे सॉल्व केल्यावरती 1 2 3 आणि 10 raised to -10 मध्ये 10 raised to -7 136 into 1.2. This is the pressure of that gas. Hey, so unit काय आहे? The unit is Newton per meter square now. So pressure is given. Indirectly it was given Hg मध्ये, mercury मध्ये height of mercury was given. त्याला कन्वर्ट केलं आता Newton per meter square मध्ये. Volume is also given. किती दिला आहे व्हॉल्यूम? 100 सेंटीमीटर क्यूब. 100 cc दिला ना व्हॉल्यूम. The volume is 100 cc. That is 100 into 10 raised to -100 into 10 raised to -6 सेंटीमीटर क्यूब दिला आहे. सो 10 raised to -6 कसं आलं? तर 1 सेंटीमीटर इज 10 raised to -2 मीटर. सो क्यूब केला सेंटीमीटर क्यूब, इट विल बिकम 10 raised to -6 मीटर क्यूब. सो व्हॉल्यूमही दिला आहे. व्हॉल्यूम इज गिवन, प्रेशर इज गिवन, ॲज वेल ॲज टेम्परेचर इज गिवन. किती दिलं आहे टेम्परेचर? क्वेश्चन नंबर 3, टेम्परेचर इज गिवन 27 डिग्री सेल्सिअस मीन्स SI युनिटमध्ये इट इज 300 केल्विन. And question is number of moles. Third question successively, third question PV equals to nRT वरती based. So काय येईल? N. Number of moles will be PV upon RT. Pressure हे आहे 1.2 136 into 10 raised to -7. Temperature किती आहे? Temperature is 300 divided by R is 8.314 into T. Sorry. PV है, हाँ V वरती वॉल्यूम है. व्हाट इज वॉल्यूम? द वॉल्यूम इज 100 into 10 raised to -6 divided by volume divided by temperature. What is temperature? It is 300. Okay, so 1 2 1 2 zeros cancel. 8.3 into 3 स्टँडर्ड आहे. RT कधी पण 300 असेल टेम्परेचर, हा 3 आणि आरचा 8.314 हे मल्टिप्लाय करून यू विल ऑलवेज गेट 25. रिमेंबर 8.314 into 3 is roughly 25. So हा रफली काय होईल? This will become 25. 10 raised to -7, 10 raised to -6 will go 10 raised to -13. 1.2 into 13 6 upon 25. आणि आता हे सॉल्व करायचं आहे. ऑप्शन्स बघा. All the options are in 10 to the power positive because right now this is number of moles, right? हे number of moles वरून number of molecules वर कसं कन्वर्ट करणार? तर we have to multiply it. Number of moles is number of molecules upon Avogadro number. आणि Avogadro नंबरची व्हॅल्यू मल्टिप्लाय केली 6.023 into 10 raised to 23. The answer will go into 10 raised to पॉझिटिव्ह नंबर. किती येईल? 10 raised to 10, राईट? 10 raised to 10. आणि हा जो फॅक्टर आहे 1.2 into 136 into 6 upon 25. रफली सॉल्व करू आपण हे. 6 4 जा 24, 4 0.3 जा 1.2 आणि 0.3 into this एक 0 शिफ्ट केला, this will become 3, this will become 13.6 and 13.6 3 जा roughly it is 40. So 40 into 10 raised to 10 म्हणजे 4 into 10 raised to 11. The closest answer to this option is beta. It is 3.86 times 10 to the power 11. So question number 3 answer is beta. 3.86 10 raised to 10. Remember CET मध्ये exact calculation is not important. You should solve it approximately. कमीत कमी time मध्ये you have to solve the question. So ह्या particular question's answer is beta. Okay, so have a look at the fourth question. At certain temperature the RMS speed of oxygen is 400. Then at the same temperature RMS speed of hydrogen will be what? Fourth question बघा. RMS speed चा question आहे. RMS speed चा formula आहे √3RT/m0. Right? So at certain temperature RMS speed of oxygen is given. Oxygen ची RMS speed दिली आहे. And at the same temperature म्हणजे temperature is kept same. R आणि 3 तसंही constant आहे. So I can say CRMS is inversely proportional to molecular weight का square root. So RMS speed of hydrogen upon RMS speed of oxygen will be inverse proportion मुळे molecular weight of oxygen upon molecular weight of hydrogen, H2. What is molecular weight of oxygen? It is 32 gram. What is molecular weight of hydrogen? It is 2 gram. So it will become 16, and if you solve it, square root of 16 is 4. So hydrogen का RMS speed and oxygen चा RMS speed मध्ये oxygen का RMS speed is 400 meters per second. If you cross multiply 400, you will get answer as 1600 meters per second. Question number 4 answer is beta. Okay, so fourth झाल्यावरती question number 5. Read question number 5. If oxygen has RMS C, then what is RMS of hydrogen? आत्ताच झालं. RMS of hydrogen काय प्रूव्ह केलं आपण? It is 400 times 4 मागच्या क्वेश्चन मध्ये. 400 was what? RMS of oxygen. आत्ताच्या क्वेश्चन मध्ये RMS of oxygen is C, then what is RMS of hydrogen? RMS of hydrogen is 4C. Option is C. Question number 5 answer is C. ठीक है. Have a look at fifth question now. Sorry, sixth question. Next one. Sixth question. At room temperature, the RMS speed of certain molecule, diatomic molecule, is found to be 1930 meters per second. Then कुठला गॅस आहे तो? At room temperature, RMS speed is found to be 1930 म्हणजे RMS speed दिली आहे. And according to the formula, it is 3RT/m0. So the molecular weight काढून finding molecular weight will help us to find the gas का type, which gas it is. Okay, किती दिली RMS speed? 1930 under root 3. R is 8.314. Temperature, room temperature म्हणजे 300 केल्विन. मगाशी सांगितलं मी हे मल्टिप्लाय केल्यावरती what do we get? 25. Correct? So it will become under root 3 into 25, 100 as it is upon molecular weight 1930. What is square root of 2500? It is 50. Square root of 3 is 1.73. Okay, इथं स्क्वेअर करावं लागणार आहे. फर्स्ट आय विल स्क्वेअर बोथ साइड्स. इफ यू स्क्वेअर बोथ साइड्स, what will be the square of this? This is roughly 2000. So what is square of it? It is 4 into 10 raised to 6 is 7500 divided by m0, and m0 will be 7500 divided by 4 into 10 raised to minus 6. 1 2 0 कॅन्सल झाले, 10 raised to minus 4 झाला, and 75/4, 4 1 जा 4, 35 is left, roughly 9 जा, and आन्सर येत आहे मॉलिक्युलर वेट किती येत आहे गॅसचं? 19 into 10 raised to minus 4 kg. एक 0 शिफ्ट केला, 1.9 into 10 raised to minus 3 kg म्हणजेच किती ग्रॅम? 1.9 ग्रॅम. इथे अप्रॉक्सिमेशनमुळे दिस विल कम आउट टू बी 2 ग्रॅम. अँड विच गॅस आउट ऑफ दिस 4, सांगा विच गॅस आउट ऑफ दिस 4 का मॉलिक्युलर वेट इज 2 gram? F2O2 H2Cl2. Answer is hydrogen. H2 का molecular weight is 2 gram. So या particular question मध्ये the gas should be hydrogen. Option is beta. So fifth झाला, sixth झाला. पुढचा रीड करा question number 7 now. Read question number 7. काय question आहे? Question number 7 is, if gas has n degrees of freedom, then what is the ratio of specific heat? हे कालच बघितलं आपण. जेवढे डिग्रीज ऑफ फ्रीडम, F बघितलं आपण काल डिग्रीज ऑफ फ्रीडमला. ओव्हर हियर डिग्रीज ऑफ फ्रीडम किती आहेत? डिग्रीज ऑफ फ्रीडम आर n. जेवढे डिग्रीज ऑफ फ्रीडम असतील तेवढी त्याची एनर्जी किती असते, एनर्जी ऑफ मॉलिक्यूल. आठवतंय कालचं लेक्चर्स, एनर्जी ऑफ मॉलिक्यूल. व्हॉट इज एनर्जी ऑफ मॉलिक्यूल? n/2 kBt. हाफ kBt इज फॉर 1 डिग्री ऑफ फ्रीडम. सो n डिग्री ऑफ फ्रीडमला n/2 kBt. एनर्जी ऑफ मोल किती होईल, एक मोलमध्ये एवोगाड्रो नंबर ऑफ मॉलिक्युल्स असतात. सो n/2 kBt इंटू Na. सो Na इंटू kBt किती होतो, RT, n/2 RT, u ऑफ मोल. अँड डेरिव्हेटिव्ह याचा घेतला, डेरिव्हेटिव्ह यू गेट विच टर्म, यू गेट स्पेसिफिक हीट ॲट कॉन्स्टंट व्हॉल्यूम, जे येईल n/2 R. स्पेसिफिक हीट ऑफ ॲट कॉन्स्टंट व्हॉल्यूम वरून स्पेसिफिक हीट ॲट कॉन्स्टंट प्रेशर कसं मिळेल, CV प्लस R, CP मायनस CV इज R. सो CV दॅट इज n/2 R प्लस R केलं तर यू विल गेट n+2/2 R. हे कसं आलं तर n/2 R प्लस R. R कॉमन घेतल्यावरती n/2 प्लस 1 इंटू R, दॅट इज n+2/2 टाइम्स R. दिस इज CP अँड CP/CV इज ॲडियाबॅटिक कॉन्स्टंट. सो ॲडियाबॅटिक कॉन्स्टंटची व्हॅल्यू काय येईल, दिस टर्म CP divided by this term, that is CV. So असं येईल n/2/2 into R divided by n/2 into R, R/2 cancel. Answer is n+2 upon n. So the answer for this is 1 plus 2 by n. Option for question number 7. Next question is 7th question, right? So the answer for question number 7 is alpha A. 7th question's answer is A. Read next question. Next question सेमच question आहे. CP/CV is asked. Question number 8. See, question number 7 मध्ये what was given की degree of freedom is n, then what is the ratio of specific heats? स्पेसिफिक हीटचे रेशो काय असेल, CP/CV. म्हणजेच तुम्हाला विचारलेलं व्हॉट इज ॲडियाबॅटिक कॉन्स्टंट. हे आन्सर आले. 8th क्वेश्चनमध्ये ओनली n इज रिप्लेस्ड बाय f. डिग्री ऑफ फ्रीडम f असेल तर व्हॉट इज रेशिओ ऑफ स्पेसिफिक हीट. आन्सर ऑब्व्हियसली काय मिळेल, 1/2 प्लस 1+2/f. सेम आन्सर येईल. सो आन्सर कुठलं मॅच होत आहे, आन्सर इज डेल्टा फॉर क्वेश्चन नंबर 8. सेम क्वेश्चन आहे, 7th आणि 8th मध्ये काही डिफरन्स नाही, राईट. सो क्वेश्चन नंबर 8 आन्सर इज डेल्टा. रीड क्वेश्चन नंबर 9. नेक्स्ट क्वेश्चन इज द 9th क्वेश्चन. सी क्वेश्चन नंबर 9 मध्ये मीन एनर्जी पर मॉलिक्यूल फॉर पॉलीएटॉमिक गॅस विथ n डिग्रीज ऑफ फ्रीडम इज. कालच झालं आहे. एनर्जी पर मॉलिक्यूल किती असते, एनर्जी पर मॉलिक्यूल आत्ताच सांगितलं, हाफ kBt इज द एनर्जी पर मॉलिक्यूल फॉर 1 डिग्री ऑफ फ्रीडम. सो जर पॉलीएटॉमिक गॅस आहे आणि त्याला n डिग्रीज ऑफ फ्रीडम असतील, सो यू हॅव टू सिम्पली मल्टिप्लाय इट विथ n, बिकॉज एव्हरी डिग्री ऑफ फ्रीडमला एनर्जी इक्वली पार्टिशन होते, इक्वली डिवाइड होते. सो हाफ kBt फॉर 1 डिग्री ऑफ फ्रीडम, n डिग्रीज ऑफ फ्रीडम आहेत या गॅसचे. सो द आन्सर विल बी n इंटू हाफ kBt. द करेक्ट आन्सर फॉर दिस क्वेश्चन, 9th क्वेश्चनचा आन्सर इज बीटा. n into half kBt, option is beta. If it is ideal gas, ideal gas degree of freedom is 3 because it has only translational freedom x, y and z. So त्यासाठी आन्सर काय येतं, 3/2 kBt, 3/2 kBt for ideal gas. But if the gas is di, tri, polyatomic, in that case the factor n will come over here instead of 3. So question number 9 answer is beta. Have a look at question number 10 now. Read question number 10. 10th question numerical आहे. Read the question properly. मोठा question आहे. The question is average translational energy and RMS speed of oxygen gas at 300 Kelvin are given. What is given? Average translational energy म्हणजे kinetic energy दिली आहे. किती दिली kinetic energy? 6.21 10⁻⁻21 जूल ऑफ ऑक्सिजन मॉलिक्युल्स. आणि त्याची RMS स्पीड किती आहे, RMS स्पीड CRMS दिली आहे 484 मीटर्स पर सेकंड ऑक्सिजनची. ॲट विच टेम्परेचर, ॲट 300 केल्विन असं दिलं आहे. आता विचारलं आहे की व्हॉट विल बी हे सगळं ॲट डबल द टेम्परेचर 600 केल्विनला काय होईल. तर रिमेंबर 600 केल्विनला कायनेटिक एनर्जीच्या फॉर्म्युलामध्ये यू नो दॅट इट इज 3/2 kBt. मॉलिक्यूलची कायनेटिक एनर्जी टेम्परेचरला डायरेक्टली प्रपोर्शनल आहे. सो कायनेटिक एनर्जी इज डायरेक्टली प्रपोर्शनल टू टेम्परेचर. सो जर तुम्ही टेम्परेचर डबल, इफ यू मेक टेम्परेचर ट्वाइस, ऑब्वियसली कायनेटिक एनर्जी विल बिकम ट्वाइस. सो व्हॉट डू वी एक्सपेक्ट? ह्याचा डबल 12.42 into 10 raised to minus 21 joule will be the answer for kinetic energy. But RMS speed won't get double because RMS speed चा formula बघितला तर it is not directly proportional to the temperature, it is directly proportional to the square root of temperature. So if temperature is made twice, double केलं तर CRMS won't become double, it will become root 2 times. So root 2 times म्हणजे root 2 into 484. root 2 is 1.414. याला 500 पकडलं मी तर आन्सर शुड गो क्लोज टू 700, थोडंसं 700 पेक्षा कमी. सो परफेक्टली मॅच होणारे आन्सर्स कुठले त्याच्यात? ह्याचा डबल 12.42 ऑप्शन ए विथ 684 आहे ना आन्सर तिथं. सो ऑप्शन ए इज द करेक्ट चॉईस फॉर क्वेश्चन नंबर 10. 10th question answer is A. Okay, so the next question is question number 11. The RMS speed of the gas is given and density of the gas is given, and question is what is the pressure? So pressure derivation मध्ये we have derived equation of pressure. If you remember, it was 1/3 nm CRMS square by V. This was the first variant. ह्याचे अजून वर्जन होते 1/3 nm is mass of the gas CRMS square by V, and mass by volume वाला last variation was 1/3 rho CRMS square. Density, RMS speed आणि प्रेशर मध्ये this was the relation. या क्वेश्चन मध्ये CRMS speed, RMS speed is given 1840 as well as density is given 8.99. याला 9च म्हणतो मी, 9 into 10 raised to minus 2 SI units. So CRMS density given, pressure विचारलं. Simply I will put it in the formula. So pressure काय येईल? What will be the pressure? Pressure will be 1/3 rho, which is 9 into 10 raised to minus 2 C square. What is square of this? आता 1840 ला मी 1800 लिहितो. What is square of 18? 18 square is 324 and 2 0च्या square is 40. So 324 into 4 zeros, this 2 zeros will cancel straight away. This is 3s are 3 into 324 is 972 into 10 raised to 2. 2 0 राहिलेत अजून. So the answer that is matching this is, बघा कुठलंच सध्या तुम्हाला वाटणार नाही मॅच होत आहे, बिकॉज द आन्सर इज गिवन इन 10 raised to power +3 +4 or +5. So what I will do is I'll shift 3 zeros, it will become 0.97 into 10 raised to 5 Newton per meter square, right? But the closest answer to this आपण इथे approximation केलं आहे 840 ला 1800 पकडलं आहे. सो आन्सर थोडं कमी आहे. आन्सर इज 1 into 10 raised to 5. The answer is beta. Question number 11, answer is beta. Read the next question, that is question number 12. Read the 12th question now. What is given? If heat given to the system is 6 kilocalorie and work done is 6 joule, what is the internal energy change? We know that heat given to the system is utilized for two purposes. First is to increase the internal energy of that system plus to perform work on the surrounding. This is the formula. Chemistry मध्ये exactly उलट लिहितो, that is work done on the system. इथे work done by the system आहे, it is work done by the system. So या क्वेश्चन मध्ये काय दिलं आहे? 6 kilocalorie heat is given, 6 kilocalorie, आणि त्याच्यातनं किती वर्क झालं आहे? Work done by the system is 6 kilojoule plus work done is 6 kilojoule and what is internal energy change असा क्वेश्चन आहे. ऑब्वियसली फर्स्ट लुक मध्ये बरेच जण म्हणतील 6 तर 0, बट हे युनिट्स आर डिफरंट. सो फर्स्ट वी नीड टू कन्वर्ट इट इनटू सेम units. Either I will convert calorie to joule or joule to calorie. The easy version is 1 calorie is 4.2 joule. 4.18 असतं, 4.2 joule घेतो. So 1 kilocalorie will be 4.2 kilojoule. So what is the energy? 6 into 4.2 kilojoule is the heat given to the system, out of which 4 kilojoule ka work is done. So what will be internal energy change? So 6 into 4.2 is 25.2 kilojoule minus 6 kilojoule will be the internal energy change, and 25.2 minus 6 is 19.2 kilojoule. This is internal energy change of the system, and that internal energy change, so answer is C. Question number 12, answer is C. Clear? Read the next. Okay, so the next question is question number 13. If the amount of heat given to a system is 35 joule and the amount of work done by the system is minus 15 joule, then what is the change in internal energy? Now again, this is question based on first law of thermodynamics. We know that in physics, how do we write the first law? The amount of heat that is given to the system is utilized for two purposes. दोन reasons साठी use होते. First is used to increase its internal energy and second is to perform work by the system. System will perform work. I'll write by system. In chemistry, we consider this as work done on system. Okay, so this is by system wala work. In this question, it is given 13th question. Amount of heat given to the system is 35 and work done by the system is minus 15. Then what is internal energy change? Obviously, solving this, you will get internal energy change as 50 joule. So question number 13, answer is A. Let's move to the next question, that is question number 14. The specific heat of gas in an isothermal process is. This is very simple question, but for that you must know what is the meaning of word specific heat. See, the formula of specific heat is Q upon M delta theta. But only formula is not important. You must also know the concept behind this. The meaning of specific heat is, for example, if I say specific heat of certain substance is, example, I'm just giving you example, is 5 calorie per gram per degree Celsius. Heat is measured in calorie, mass in gram, temperature in degree Celsius. What is the physical significance or what is the meaning of this term 5 calorie per gram degree Celsius? This means if I take this substance, suppose example के लिए, if I say this is example, it is copper. Actually copper का specific heat is less, but just example, for example point of view, if copper का specific heat is 5 calorie per gram per degree Celsius, it means if I take 1 gram of copper cube or any shape of 1 gram of copper, if I take 1 gram of copper और उसका temperature right now room temperature है, let us say 27 degree है. If I want to increase it by 1 degree Celsius, तो कितना energy उसको देना पड़ेगा? How much energy I should give it? That energy is 5 for this material. Obviously, it will be different for different material. For example, water के लिए 27 से 28 तक लेके जाने में 27 to 28 1 gram of water को maybe it will require another value. For water it is 1 calorie. So every substance has got its own specific value, specific heat का value. Right now the question is gas का specific heat क्या होगा in isothermal process. Now see, isothermal process we have seen in the lecture, theory lecture, that isothermal process is the process in which temperature remains constant. So delta theta कितना आएगा? 0. So specific heat in isothermal process will become Q upon M into delta theta 0 है, so it will go to infinity. So specific heat in isothermal process is infinity. आणि असाच एक क्वेश्चन विचारतात एडियाबॅटिक प्रोसेससाठी. इन एडियाबॅटिक प्रोसेस व्हॉट इज स्पेसिफिक हीट? नाउ स्पेसिफिक हीट इन एडियाबॅटिक प्रोसेस काय आहे? तर एडियाबॅटिक प्रोसेस इज द प्रोसेस वेअर हीट इज नॉट गिवन और टेकन आउट ऑफ द सिस्टम. सो हीट इज 0 आहे, सो स्पेसिफिक हीट विल बी 0. So this is the answer for question number 14. Okay, the next question is question number 15. In an isothermal process, the volume of an ideal gas is made half, is halved. Then one can say that what is going to happen? See, isothermal process बोलल्यावरती whenever isothermal process is given, समजून जायचं iso means same, therm is related to temperature. Temperature remains same. There is no change in temperature. Now isothermal process मध्ये temperature change नाही झालं तर obviously kinetic energy of gas will not change or internal energy of gas will not change because internal energy is the function of temperature. So if in isothermal process do anything, internal energy of gas will never change. तुम्ही volume half करा, double करा, won't make any difference. Internal energy will not change, right? So 15th मध्ये internal energy of the system increases, internal energy of the system decreases. हे दोन ऑप्शन wrong आहेत. Right? Now next is work done by gas is positive, work done by gas is negative. Now how to deal with this work done wala part? Q, the amount of heat that is given to the system is utilized for two purposes. increase its internal energy and perform work, right? But now if the process is isothermal, this will be 0. So whatever heat we are giving, that will be utilized for doing work by the system, expansion. So expansion jab hoga, we will give heat, work done will be positive expansion. This is not chemistry. Chemistry mein expansion we take negative work done, because that is work done on the system. This is work done by the system. Expansion mein positive, contraction compression mein negative. So in this case volume is made half, so obviously work done will be negative. दूसरा approach ऐसा है, work done is P delta V, so obviously delta V will be negative because final volume is less, initial volume is more. Volume initial is more, it is made half, so final volume is less, so work done will be negative. So as answer का ये 15th answer is work done by gas is negative, option is delta. 15th question's answer is delta, right? Read question number 16. Read question number 16. See, in 16th question, during adiabatic expansion of gas, 2 moles of gas, during adiabatic expansion of 2 moles of gas, internal energy was found to have decreased by 100. Then what is the work done in the process? Very simple question. You must understand what is the meaning of adiabatic. There are 2 standard processes, isothermal जहाँ पे temperature change नहीं होता, adiabatic जहाँ पे heat is neither given out or taken in by the system. So adiabatic process में if I don't give any heat, then इस formula में LHS will always be 0, right? So whatever is going to happen, that is going to happen between this internal energy and work done. Means if internal energy of the system increases, work done will decrease. नेगेटिव होगा वो, मीन्स इंटरनल एनर्जी 100 से बढ़ेगा तो वर्क डन नेगेटिव हो जाएगा 100 से. सो इन क्वेश्चन नंबर 16 एडियाबेटिक प्रोसेस में इट इज फाउंड दैट इंटरनल एनर्जी डिक्रीज हुआ बाय कितना 100 जूल. देन वर्क डन बाय द सिस्टम विल बी पॉजिटिव 100 जूल. दिस इज नेगेटिव, दिस इज पॉजिटिव, एडिशन शुड बी 0. सो आंसर इज बीटा, work done by the system is plus 100. 16th का answer is B. Okay, so the next question is question number 17. A unit mass of liquid with volume V1. V1 is the volume of liquid. It is liquid state, right? Is completely changed into gas. This is completely converted into gas of volume V2, right? So liquid of volume V1 is converted into gas of volume V2 at constant external pressure. External pressure is kept P, constant external pressure, and temperature is given T. If the latent heat of evaporation is L, latent heat of evaporation means what? It is amount of heat required to convert a unit mass of substance from liquid to gas. Liquid to gas convert करने में कितना, how much energy is required, that is called as latent heat. Since the mass of the gas is unit, the amount of heat required will be L itself. L is the latent heat and same amount of heat is given to this gas. How much heat is given? L is given because it is a unit mass. Then increase in the internal energy will be, okay? So what is the heat given to the system? The heat given to the system according to the first law, the heat given to the system is equal to L, right? What is internal energy change? That is asked. And what is the work done in this process? Expansion, volume expansion hai. So work done against constant pressure is V2 minus V1 times pressure. So what will be the answer for internal energy change? The internal energy change will be L and minus this part, minus P times V2 minus V1. So answer is delta. Question number 17, answer is delta. Okay, so read the next question, that is question number 18. Question number 18. Read question number 18. 2 kg of water is converted into steam at boiling point, by boiling at atmospheric pressure. The volume changes from 2 into 10 raised to minus 3 to 3.34. The work done by the system is what? Work done by the system का formula होता है P delta V when volume expansion takes place at a constant pressure. Now against what constant pressure it is taking place? Against atmospheric pressure, which is 1 into 10 raised to 5. And what is the change in volume? Final volume is 3.34 minus the initial volume is 0.002. 2 into 10 raised to minus 3 is 0.002. So answer is roughly this minus this, negligible is, right? So answer will be 3.34 into 10 raised to 5, which is 334, 2 0 isko diye to 10 raised to 3 joule is kilojoule. So answer is 334 kilojoule. The closest answer is A, 340 kilojoule. So work done by the system is 340. Why positive? Expansion. Expansion mein work done is positive by the system. 18th का answer is A. ठीक है. Read question number 19. Read question number 19. The efficiency of Carnot engine is 50%. Now this Carnot engine or Carnot cycle we don't have in our syllabus, state board syllabus, but still I'll explain. Very simple formula it is. The efficiency of the engine is 50% when the temperature of outlet is 500. In order to increase the efficiency to 60%, what should be the temperature? Keeping the temperature of intake same, what should be the temperature of outlet? See, what we have studied in heat engine, if you remember, if this is heat engine, it takes the heat from the source. कितना देता है? Q1, for example 100 joule. उसमें से it will do certain amount of work, which is, let us take example 30 joule, and remaining everything it will give out to the surrounding, that is Q1, that is equal to 70 joule. 100 में से 30 work, 70 given out. What is the efficiency of this engine? The efficiency of this engine is W work done upon heat provided to that engine, that is 30 by 100 for this example, it is 0.3 or 30%. Correct? This is how we find the efficiency. But according to Carnot cycle, if the cycle is Carnot cycle, then Carnot cycle में Q1 by Q2 is equal to T1 by T2. इसका टेम्परेचर T1 है सोर्स का, एंड सिंक का टेम्परेचर T2 है. देन Q1 by Q2, sorry, this is Q2, right? Heat given out is Q2. I have written Q1 over here. It was Q2. Q1 by Q2 is T1 by T2. This is the condition for Carnot cycle. So Carnot cycle के लिए efficiency का formula will convert to, efficiency का actual formula क्या है? Work done, वो है Q1 minus Q2 upon Q1, which is 1 minus Q2 by Q1, right? So this can be written as, according to Carnot cycle, 1 minus T2 by T1. T2 by, okay? So using this formula now, what is the given condition? The condition is efficiency of Carnot engine is 50% when the outlet, temperature of outlet is 500. So if the temperature of outlet is 500, 0.5, 1 minus outlet क्या होता है? T2 is 500, right? 500 upon T1, inlet का temperature क्या है? We don't know, but I can solve it. क्या आएगा आंसर? If I take 500 by T1 on left side, 500 by T1, तो 1 minus 0.5 will go on the right side. 500 upon T1 is equal to कितना आएगा? 0.5. So T1 is equal to 1000. 5.5 will go down. So इसका temperature, inlet का temperature we have now, it is 1000 Kelvin, right? Now the question is, if I want to increase the efficiency, by keeping inlet temperature same, इसको same रखना है. If I want to increase efficiency, what should be the temperature of outlet? Temperature of outlet should be what? So if I want to make it 60%, मतलब 0.6, so 1 minus what should be the outlet temperature? That we are going to calculate. If the inlet is kept 1000, so T2 by 1000 left side को जाएगा. 1 minus 0.6 is 0.4, T2 equals to 400. So the temperature of the outlet should be 400 Kelvin. Question number 19 का answer is C. 19th का answer is C. Okay, so the next question is question number 20. Half part of ice block is covered with a black cloth and the rest half of it is covered with a white cloth. Then it is kept in the sunlight, which after some time cloths are removed to see the melted ice. Which of the following statement is correct? Now the part which is covered with a black cloth and the part which is kept open, the black cloth will absorb more heat and therefore the melting of ice will be more in case of black cloth. So the answer is ice covered with the black cloth will melt more. Option is A, as black cloth is a good absorber. Question number 21. There is a rough black spot on a polished metallic plate. It is heated up to 1400 Kelvin approximately. Rough black spot on a polished plate. Then it is taken into dark room. Which of the following statement is true? There is a polished plate and there is a dark spot on it. It is heated to 1400 Kelvin and it is taken into dark room. Then the plate and the black spot cannot be seen in the dark room. The spot and the plate will be equally bright. In comparison with the plate, the spot will appear more black. In comparison with the plate, the spot will appear, or the spot will shine more. Now see, if you consider a plate and the plate is polished, means it is a good reflector, and on this plate if there is a dark spot, means it's a good absorber. So good reflector, good absorber. When you heat this, good absorber becomes a good emitter, good reflector becomes, bad absorber. Right now this is a good absorber, this is a bad absorber. So bad absorber is a bad emitter, good absorber is a good emitter. Remember, good absorber is a good emitter and bad absorber is a bad emitter, obviously. So out of these two, right now polished is a bad absorber, so it will emit badly, means taken in the dark room this will shine brightly as compared to the rest of the plate. So the answer is delta. 22. An ideal black body at room temperature is thrown into furnace. It is observed that when you throw a black body into furnace, it is a good absorber. So once you remove it out of a furnace, it will emit radiations. It will be good emitter. Initially it is the darkest body and later times it cannot be distinguished. It cannot be distinguished at all times. It is the darkest body at all times. Initially it is the darkest body, in later times it becomes the brightest. Okay, when ideal black body is thrown into furnace, initially it will absorb all the radiation. So initially it will be dark, it will be black, but once its temperature increases, it will start emitting the heat, and therefore you cannot distinguish. Finally it will be the brightest of all the material in the furnace. Later time it is the brightest, so answer is delta. Initially it is the darkest, and finally initially it is the darkest, it is the good absorber, and finally it is a good emitter. So question number 22, answer is delta. Initially it is the darkest and later it is the brightest. 23rd question now. Read question number 23. Question number 23 is based on Wien's displacement law. Okay, the intensity of radiation emitted by sun has maximum value. Lambda max sun का जो है, it is 510 nanometer. It is given sun, and that emitted by the North Star. North Star emits wavelength maximum. Its peak, North Star peaks at 350 nanometer. So obviously इसका temperature, North Star का temperature will be greater than sun. If these stars behave like black bodies, then what is the ratio of surface temperature of sun to North Star? Now this is Wien's displacement law, where lambda max is inversely proportional to temperature. Correct? So temperature को inverse proportion है. So temperature of sun upon temperature of North Star will be lambda max of North Star upon lambda max of sun. What is lambda max of North Star? 350. 510 nanometer cancel. So 35 upon 51. The closest answer, if you divide it 35 by 51, इसको 50 पकड़ लिया, then it is into 2. So 70 by 100, answer is 0.7. So option is, the closest answer is A. The temperature of sun upon temperature of North Star is 0.7, the ratio. Answer for question number 23 is A. Next question, question number 24. Read 24th question now. The maximum energy in thermal radiation of source occurs at 4000 angstrom unit. Maximum energy is at 4000 angstrom unit. Lambda max is 4000 angstrom unit given. Then what is the temperature of the source? Use the formula. Wien's displacement law is B by T. B is Wien's constant. So कैसे निकालेंगे टेम्परेचर? टेम्परेचर विल बी 2.898 इंटू 10⁻³ B का वैल्यू, टेम्परेचर ऊपर, लैम्बडा मैक्स नीचे, अपॉन लैम्बडा मैक्स का वैल्यू 4000 एंगस्ट्रॉम यूनिट इज 4 इंटू 10⁻⁷, राइट. दिस इज अप्रॉक्सीमेटेड टू 3 इंटू 10⁻³ अपॉन 4 इंटू 10⁻⁷, -7 ऊपर गया तो 10⁴, 3/4 इज 0.75 इंटू 10⁻⁴, which is 7500 Kelvin. So the temperature of that particular object is 7500 Kelvin, which is option delta. Question number 24, answer is delta. Temperature of two bodies A and B are 727 degrees Celsius, that is 1000 Kelvin, and 327 degrees Celsius, that is 600 Kelvin, right? And question is, what is the rate of heat radiated? Now this question is based on Stephen's law. What is Stephen's law? Energy emitted by the body is sigma T⁴ if it is a black body. If it is a normal body, then it is E sigma T⁴. And in this question, heat radiated is asked. What is heat radiated? Heat radiated is amount of heat emitted per unit time per unit area. Heat radiated. Okay. So the heat that is radiated per second, if it is asked, then it will be proportional to E A sigma T⁴. This particular question, the data is not mentioned that two bodies are identical. If the bodies are identical, then E and A will be same. Only the heat radiated will be proportional to temperature raised to 4. So heat emitted by A upon heat emitted by B will be temperature of first body upon second body raised to 4. 5/3 raised to 4, that will give 625/81. So the option that will match is C. Question number 25, answer is C. Okay, so let's have a look at the next question. Question number 26. Read 26th question. Similar question we have solved in CET, previous year CET exam questions. Similar question it was. A rectangular slab of area 8/4, area is given 8/4, rectangular slab का, and its temperature is 127 degrees Celsius, मतलब 400 Kelvin, 400 Kelvin, emits E energy per second. Per second E it emits. Now if the length and the breadth are reduced to half, इसको half कर दिया, so obviously area will become 1/4, area will become 1/4, and the temperature is raised to 327. 327 को temperature increase किया, means 327 means कितना है temperature? 327 means plus 273, that is 600 Kelvin. Temperature is increased to 600, area is made half, then how much energy it will emit per second? So energy emitted per second is directly proportional to area T⁴ according to Stephen's law, right? So area multiplied on the right side, amount of heat radiated per second, that is E given over here, is directly proportional to area in T⁴. So first case में if it is emitting E, in the second case जब temperature बढ़ा दिया, area कम कर दिया, what will be new E? So I will write E2/E1 is equal to original area is A, final area कितना है? A/4, original temperature is 400, final temperature is 600 raised to 4. 2 and 3. 3 raised to 4 is 81, 2 raised to 4 is 16, A cancel, this is 1/4. So answer will be 81/64 as E2/E1, E1 cross multiply किया, तो this much energy it will emit per second after making these changes. So question number 26 का answer is A. Okay, this is 26th question, answer is A. Read question number 27, 28, 29, 30. All questions are based on Newton's law of cooling. All questions are based on Newton's law of cooling. 27 के आगे. See how to solve Newton's law of cooling वाले questions. Temperature difference 65.5 to 62.5 तक ड्रॉप हुआ टेम्परेचर फर्स्ट केस में in 1 minute. In 1 minute. Okay. रूम का टेम्परेचर इज 22 डिग्री सेल्सियस, 22.5 सॉरी, रूम टेम्परेचर इज theta naught, we call it as 22.5 degree Celsius. The temperature drops. How long will it take to drop temperature of from 65.5 to 40.5? How much time it will take to drop from 65.5 to 60.5? So we need to use how much time it will take. We need to use the formula, and Newton's law of cooling states that the rate of cooling is K theta minus theta naught. Yesterday in the lecture I have explained this is the average temperature. So what is temperature drop, rate of drop in the first case? In the first case the drop is 65.5 minus 62 is 3 upon 1 is equal to K, which we don't know. Theta is the average. What is the average of 65.5 and 62.5? See, 65.5 and 62.5 का average will be, दोनों का average 65 and 62 का average, 65.5 and 62 का average can be calculated, oral you can calculate. The difference 3 है, so 1.5 नीचे 1.5 ऊपर, it will be 64. So 64 minus 22.5, correct? 64 minus 22.5, that is equal to 42.5 is K, sorry, is this. So K equals to क्या आएगा? 3 by 42.5. This is the value of K that we have achieved from the first condition. Now using the value of K you can find second condition. Second condition में कितना drop है? 65.5 to 40 means the drop is, what is d theta by dt? 6 by t, which we don't know, is equal to K, जिसका value we have derived, into theta minus theta naught. Room temperature is still 22.5. And what is the average of these two? इन दोनों का average is 43, correct? 43.5. 43.5 is the average. 43.5 minus 22.5 is 21 into 3 upon 42.5 is equal to 6. यहाँ पे t है डिनोमिनेटर में, क्रॉस मल्टीप्लाइंग दिस विल बिकम 83 is equal to 21t, t equal to 83 by 21. So answer is roughly 4 minutes. Roughly the answer is 4 minutes. Nearest value 4 minutes. Option for question number 27 is A. Okay, so using the first condition we have calculated K. Using the second, using this value of K, second condition का time we have calculated. राइट, एवरेज कैलकुलेशन कैसे करना है? एवरेज कैलकुलेट कैसे करते हैं? तो डिफरेंस कितना है 46.5 और 40.5 में? 6 का डिफरेंस है, मेक इट हाफ, 3 यहाँ से नीचे 3 यहाँ से ऊपर, सो 43.5 इज द एवरेज. सिमिलरली आई हैव डन एवरेज ओवर हियर. ओके, सो क्वेश्चन नंबर 27 आंसर इज ए. रीड नेक्स्ट क्वेश्चन, 28th क्वेश्चन. अ लिक्विड कूल्स फ्रॉम 50 डिग्री to 45 degree in 5 minutes. A liquid cools from 50 to 45 in 5 minutes. Further, from 45 to 41.5 in next 5 minutes. Then temperature of the surrounding is what? Okay, so what is the first condition? 50 to 45 in 5 minutes. And then 45 to 41.5 in next 5 minutes. Then what is the room temperature theta naught? I will just write the equation. What is the equation? d theta by dt is K theta minus theta naught. First condition में if I use it, what is temperature difference? 5. कितने टाइम में? 5 minute is K, which we don't know. Theta average इन दोनों 47.5 minus room temperature we don't know, theta naught. Condition number 1. Condition number 2. What is the difference? 3.5 upon what is the time? 5 equals to K, which we don't know. Average temperature. इन दोनों का एवरेज, इन दोनों का डिफरेंस कितना है? डिफरेंस इज 3.5, उसका हाफ करना है. व्हाट इज हाफ ऑफ इट? 1.75. सो 1.75 नीचे 1.75 ऊपर, सो 41.5 प्लस 1.75 you will get 43.25 as the average. 43.25 minus theta naught. Solving these two equations simultaneously, that is dividing them, you will get the value of theta naught. See, k will cancel, 5 will cancel. 5 by 3.5, that is I can write it as 50 by 35 equals to 47.5 I will prefer it as writing it as 95 by 2, 47.5 is 95 by 2 minus theta naught upon this. I will try to write it as, इसको integer में if I want to write it in fraction, I need to multiply it with 4 and divide by 4, right? इसका fourth multiplication, fourth multiple, if I multiply it by 4, it will be 173 by 4 minus theta naught. And on cross multiplying, this is first of all 5 tens are and 5 sevens are. क्रॉस मल्टीप्लाई किया अगर 1730 by 4 minus 10 theta naught is equal to, ये क्रॉस मल्टीप्लाई किया 95 into 7 by 2 minus 7 theta naught. Theta naught, 10 theta naught will go on the right side. 10 theta naught minus 7 theta naught is 3 theta naught is 1730 divided by 4 minus, what is 95 sevens are? 7 5s are 35, 7 9s are 63, 66 by 2. If I want to solve it, I need to make it 4, so इसको into 2. What is 6? 65 का double, it is 1330 by 4 और यहाँ पे 1730 by 4 minus equals to 3 theta naught. And इनका difference जो है, the difference is 400 by 4, that is 100. So 100 equals to 3 theta naught. So theta naught or the room temperature comes out to be 100 by 3, that is 33.3 degrees Celsius. So question number 28, answer is beta. Right? Now the second last question, 29th question. Read question number 29. Similar question it is, hot water cools from 60 to 50. Hot water cools from 60 to 50 in 10 minutes. And then to 42 in next 10 minutes. Again, what is the room temperature? Same question, just the values are changed now, this time. See, water cools from 60 degree to 50 degree in 10 minutes. 50 degree to 42 degree, another 10 minutes. Room temperature कितना है? What is room temperature? That is the question. So if I use the formula, d theta by dt is k, theta minus theta naught. First equation क्या आएगा? Theta minus temperature change is 10 by time is 10 is k, which we don't know. Average temperature is 55 minus theta naught is to be calculated. First condition. Second condition में what is temperature change? 8 by time is 10. Constant we don't know. Average temperature of these two is 46 minus theta naught. If you take the ratio 10 10, k will cancel. 10 by 8, this is second equation, 10 by 8 is 5 by 4 is 55 minus theta naught upon 46 minus theta naught. Cross multiply to get the value. If I cross multiply, 5 into 46 is 230 minus 5 theta naught is equal to 4 into 55 is 220 minus 4 theta naught. Okay, 5 theta naught will go to the right side, 220 will go to the left side. So answer is 10 degree, theta naught equals to. So question number 29, answer is C. Okay, so the last question. A body cools in 7 minutes from 60 to 40, 7 minutes. What time it will take to cool from 40 to 28 if surrounding temperature theta naught is 10 degree? How much time it will take over here? See, first condition is the formula of Newton's law of cooling is d theta by dt is k, theta minus theta naught. So if I use this formula, what is d theta? Temperature change is 20 by time is 7 is equal to k, constant we don't know. Average temperature 60-40 का average is 50 minus theta naught is 10. So इसका आंसर 40 है. So 40k is 20 by 7. So k equals to 22 za. K is equal to 2 will go down, right? 1 by 14. So first condition will give us the value of k. Now using this value of k, I will try to solve the second case. Second condition में question is how much time will it take to cool from 40 to 28? So 40 to 28 में what is d theta? 40 minus 28, that is 12 by कितने time में, that we don't know, let us keep it as t, is equal to k जिसका value we have derived 1 by 14. थीटा माइनस थीटा नॉट, इन दोनों का एवरेज कितना है? व्हाट इज एवरेज? डिफरेंस कितना है? डिफरेंस है 12. मेक इट हाफ, 6. इसके 6 ऊपर, इसके 6 नीचे. इफ यू गो डाउन बाय 6 यू विल गेट 34. इफ यू गो अप 6 यू विल गेट 34. सो एवरेज इज 34 माइनस रूम टेम्परेचर इज 10. So 34 minus 10 is 24 by 14 is 12, 12 by T. 12 2s are 24, 2 7s are, so T equal to 7 minutes. So after another 7 minutes, you will find that the temperature will drop from 40 to 28. So question number 30, the answer is 7 minute, option is C. So these were the solutions.